Last time we said that for us to test whether mu I still belongs on mu naught, we really need to test, is mu naught equal to mu I? This thing is almost kind of misleading. Books always mention this, and it actually turns understanding into confusion. So the way that I will do this is to have a logical way of proving whether mu I still belongs on mu naught. So here we go. First, if something belongs on a certain distribution, for example, mu I plus 1, mu I minus 1, if all of this belongs on this distribution, wouldn't it follow the probabilities of this distribution? Meaning if mu I has a lower, as you can see, it has a lower probability than the mean, then we would normally see it in less number of occurrences compared to the mean, right? So from that, if we would check the probability of mu I, and it corresponds to what its probability should be according to the x naught distribution, then we would surely know that mu I belongs to that distribution. So that's the way to really check whether mu naught is equal to mu I, is to check whether whether mu naught is equal to mu 1 is to check whether mu 1 belongs to that distribution. So let us change this into belongs, whether mu 1 belongs to the original distribution. So how do we do that? As I said, we check whether mu 1 behaves as what the distribution expects it to behave as. So we would check on that. How do we check on that? Well, first, we need to find where mu 1 is. How do we find where mu 1 is? Well, for us to find where mu 1 is, we need to change it into a z-score, because that's the only way we can find where mu 1 belongs, where mu 1 is placed on this. It can be here, it can be there, it can be here, it can be there, right? We don't know where it is, so we need to find where it is, and we need to do a z-score. So how do we do a z-score? Well, it's just equal to the statistic we're testing, which is mu 1, minus the mean of the population, or the mean of the distribution we wanted to test it on, which is mu 0, all over the standard deviation. The standard deviation of the sampling distribution. So you might say that it should be like this, right? Sigma. But beware, this is not just a distribution. This is a sample distribution of the sampling means, a sampling distribution of the sample means. So it means it needs to be sigma all over the square root of n. So that is how we change this statistic into another statistic that would correspond to a position in this x naught distribution.